Hello, my dear subscribers. It's very cold. Everybody is quite a bit frozen. And during these times, it's very tough to study, I know, but you have to. Exams are near. Today, I just thought of just to make the temperature a bit high. I thought, let me cover calorimetry. Calorimetry, I have seen students struggle in that. Actually, the matter is in calorimetry, you have to ascertain by seeing the problem. I'm talking about numerical problem. In calorimetry, whatever problem you come across, you just have to find out who is releasing heat and who is absorbing heat. If the heat is released, in how many steps it is released? If the heat is absorbed, what are the steps in which heat is absorbed? This is not a preliminary video for calorimetry. If you require such a very preliminary video, that I can do. Now, what I am just explaining you is, if suppose in some question you are being given this kind of a temperature time curve, okay? Here you see time is plotted along x-axis and temperature along y-axis. And you see over here what the question is. Suppose a piece of ice is heated at a constant rate. The variation of temperature with heat input is shown in this graph, okay? So a piece of ice is being heated. You can see the starting point is A. It is at minus 10 degrees centigrade. So first of all, the temperature of ice changes from minus 10 degrees to point B, that is 0 degree. Okay. So for this part, I mean from A to B, this part, here you find there is a change of temperature. So temperature change occurs at this point. Okay. Now, when temperature change occurs at this point, it's very clear to you that whatever heat is absorbed by minus 10 degree ice to convert it into 0 degree ice, over there, how will you calculate the amount of heat absorbed? H1 will be mass of ice into specific heat capacity of ice into change of temperature, theta 1. Now, what is this change of temperature theta 1? What did I say? It's mass of ice into specific heat capacity of ice into change of temperature. Okay. So what is the final temperature? The final temperature is 0 degree. What is the initial? It's minus 10 degree. And let me tell you, don't confuse yourself. This C is specific heat capacity of ice and it has a different value. When there is a change of temperature for ice, you have to know the specific heat capacity of ice. Don't use water then. All right. So the change of temperature is 0 minus minus 10. What I mean to say is this will be MCI and there will be 0 minus of minus 10 degrees. Okay. And what you get over here is M into CI into, this is minus minus is plus, into 10. Okay. So you have to see what is the unit of the specific heat capacity of ice. I can do numerical problem. Any numerical problem I can just discuss it for you. Just this is a preliminary, you can say, introduction to solving numerical problem that are commonly asked in ICSE and CBSE board. Now, the ice at minus 10 degree goes to 0 degree ice. Then from B to C, B, C. Now this part signifies a condition when there is no change of temperature. See, point B also signifies 0 degree, point C also signifies 0 degree. What does that mean? It means 0 degree ice gets converted to 0 degree water. What I mean to say is from B to C, there is no change of temperature, theta, no. There is no change of temperature, theta, okay. What happens then? From B to C, what we get is 0 degree ice to 0 degree water. Okay, 0 degree ice to 0 degree water. Okay, I just wrote inside this part. Okay, I think you can understand. Now, from here, what we have is from 0 degree ice to 0 degree water. What does that signify? That signifies latent heat which is being absorbed, isn't it? There is a change of only state. You see, ice to water, no change of temperature. So change of state occurs at this condition. So they commonly ask, what does this part signify? What does BC signify? So BC part signifies what? It signifies change of state. Done? Then after this, you see C to D. So from C it's 0 degree, and then to D it's 100 degree. Okay, from C to D, during this time we have a change of temperature from 0 to D. D is 100 degrees. So what is happening is 0 degree from C to D, 0 degree water gets converted to 100 degrees centigrade water. There is no other thing written here. It could be another parallel line to the time axis. I'll discuss it later. Just now what we have is 0 degree water to 100 degree water. So again, when you calculate the amount of heat absorbed, H2 will be mass of water, which is the same as mass of ice, where we started, then specific heat capacity of water, then change of temperature is 100 minus 0, isn't it? It is as simple as that, and you have to keep in mind what is the unit of mass, what is the unit of CW that I told you. I can discuss it in a separate numerical problem. So what we have is, in this temperature time curve, you have minus 10 degrees ice getting converted to 100 degree water. So it doesn't happen in one step. That is what I told you in the introduction. I told you that the ice at minus 10 degrees gets converted to 100 degree water in how many steps? In 3 steps. So what are the steps involved? This is actually a heating curve, you can see, because the temperature of ice is actually rising up and getting converted to water. And just now I said there can be another parallel line at point D to the time axis. That means, what I mean to say is, here you can have something of this sort up till point E. So your graph can look like this also. Okay, your graph can look like this. What does that mean? It means water at 100 degree getting converted to steam. That is water vapor at 100 degree. Okay, so water at 100 degree to water vapor at 100 degree. What is happening here? It's latent heat of vaporization. This is latent heat of fusion at B, C, and then from D, E, it will be latent heat of vaporization. Again, what do you need over there? Over there, you need M into L. Over here, like this, for change of state, the heat H dash will be ML. In the same manner, here it will be ML dash. You know, latent heat of fusion of ice and latent heat of vaporization of water, they are different. So if you call this as L1, you have to call here ML2, where L2 determines the, or shows the latent heat of vaporization of water. Okay. So this is the whole temperature time curve. Okay, temperature time curve. And what we have is, what over here, there are 2 other examples which I shall discuss with you. So let's proceed for that. This is the part of calorimetry that I am discussing here. It's conversion of water to steam and then ice to water. just to make you understand what are the steps involved. Sometimes we get confused, our children gets confused that how to actually determine the steps. First, let me tell you, water at 70 degree doesn't jump into steam. You know, steam is 100 degrees centigrade, okay? It's known to you. First, you have to understand water at 70 degree first absorbs heat to come to water at 100 degrees centigrade. So in this step, what is involved is the heat absorbed can be calculated with the help of MC theta 1, where theta 1 is 100 minus 70. Let me tell you, theta 1 equal to 100 minus 70 degrees centigrade. That is 30 degrees centigrade. This part, for this part, water at 70 getting converted to water at 100 degree. Then only water at 100 degree gets converted to steam. And you see here temperature change is not involved. What is involved? Involved is change of state. What is involved is change of state. The heat absorbed here is calculated as M into L, where L is the latent heat of vaporization of water. At 100 degrees centigrade, it gets converted to 100 degrees steam. So this is latent heat involved. Here, change of temperature is involved. Wherever change of temperature is not involved, you'll know there is a change of state. So, change of state occurs here. Okay, this is one example. Another example is here. You see, I have taken ice at 0 degree and I want to convert it into water at 100 degree. In the other video that I have made in physics is easy with AM, please do like and subscribe and do visit the channel if you want to get a clear insight into the problems that you solve every day. Sometimes you do solve your problems with the help of your teacher, with the help of your book, but many times you carry different confusions in your mind. I feel I'll be able to help you in that, to clear the confusions. So ice at 0 degree gets converted to water at 100 degree. It doesn't happen like that. First, ice at 0 degree gets converted to water at 0 degree. You see, from ice 0 degree to water at 0 degree. This is the graph where I explained it in the long video. Please do visit the channel to see it. Here you see what we have is this water then gets converted to water at 100 degree. So this is ml because change of state is involved, and this is mc theta. Do visit my channel for more insight. Thank you.